Hey, you're back. Thanks for checking out the shifted axis videos. I'm assuming that you've watched the ones on the disk method that we've done. We're going to skip to ones that involve now washer method. That means that when we revolve a solid or we revolve a region around an axis, it's going to create some part that has a void in it or a hole. Here is a washer method one. The radical y equals square root of x plus 1. Okay, square root of x is kind of like that bent piece, but I'm shifting everything up 1. 1, 2, 3, 4, and then I go up 2. Here's the square root of x plus 1. The second border is y equals 1. Okay, that's that flat line, horizontal line there. And then x equals 4 creates a region. Here it is. Shaded for your edification. We revolve it around y equals -2. So I'm going to make my axis there. That is y equals -2, and it's good to put your little rotational identification that we're revolving around that axis. It's not the y-axis anymore, it's y equals -2. So it's still going to be kind of a vertical rotation, but there's some extra added space in there, so that means our radius is going to change. It used to be where if it was just around the y-axis, we didn't have to subtract anything or kind of wiggle around to see what the new radius was. Here's how that makes this one different. I'm going to kind of project that piece about the axis. 1, 2, 3, 1, 2, 3. So I think it's going to look something like this. And I'll shade it in just to show that that is another shaded region. And then as we are revolving, it's good to imagine a small tiny sliver of dx and then having it project out to see what the result is going to be when that thing is rotated. There's going to be a void. First it's going to be a big circle that's cut, and then that void creates a small circle. That's why this is a washer. And so now we got to analyze what is the radius of that washer. There's a large radius that sweeps out the big circle, and then there's a smaller radius that cuts out the inside circle. With this shifted axis, here's what you need to think about. Our large radius here, we want to think about from the farthest most on the number line in terms of, as we're looking at this piece, let's see, we have, that is radical x plus 1. And then we need to take away that distance, which is -2. So it's square root of x plus 1 minus minus -2. That becomes square root of x plus 3. That's our big radius. Our small radius is where this flat part is here. That is going to be, let's see, that's the line 1 minus -2. If we think of it as a number line, that means that is 3. And it kind of makes sense that if that's 3, yeah, that's going to make a circle that is pi r squared, or like 9 pi that we're going to take out. So we're going to use those two radii to express now. I'm going to go right to the volume. It is pi times the integral, we'll fill in the limits of integration, of big radius squared, so that's radical x plus 3 squared, minus small radius squared, which is 9. and that is in terms of dx. And our limits now, we're going from, let's see, the line x equals 0 all the way out to x equals 4. That sweeps all of the region. That is our expression of our integral. We'll do another one that involves a little bit different thinking here, because now our region is going to be, it's in terms of x equals y plus 3 squared. So here are our functions. X equals 4, that's that one. X equals y plus 3 squared. Let's see, if x equals y plus 3 squared, then that means the square root of x equals y plus 3, and that means y equals radical x minus 3. So we are, that means plus or minus y plus 3 is radical x minus 3. I need to back up a little bit. Back up by erasing. And what? And so that means like the square root of x could be y plus 3, or the square root of x could have been negative y minus 3. Let's go with the first option. That means y equals radical x minus 3. That's the square root of x. It's got that bending in the first quadrant feature, and then it's brought down 3 units. So my new origin is really 0, negative 3, and then the square root of x behaves as normally. Here is one part of it. And so the other part, that negative sign with the square root, that means negative y equals radical x plus 3. That means y equals, it's the opposite, radical x minus 3. That means the square root sign has been flipped over the y-axis and brought down 3. That really just creates the mirror image of the function that we did. This is the function x equals y plus 3 squared. Now, if you have a better option for graphing it, like you could make it a simple table, that works too. I just wanted to kind of share that option with you to create that function. All right, third function, y equals negative 3. Looks like we're cutting right through that sideways parabola, and y equals negative 1. That creates a space that is, let's see, is it this part right there? We are revolving around the line y equals 1. So here, I'm going to make this in black right now. Here is our line, our new axis, y equals 1. And that is, I'm going to put the axis of rotation notation there. Okay, we're revolving around that line, so that means I'm just going to make a quick reflection. 4, 1, 2, 3. I think it will end up being like this and like that if we reflect correctly. And so that region, when revolved around the line y equals 1, if we pretend we have a little sliver, let's project that out. That will create a washer when revolved around that axis. This is a washer. And so we've got to analyze, okay, what is the big radius? The one that sweeps out the entire circle. And then what's the small radius? The one that sweeps out the cutout portion. Think of this as a number line, and what is the radius of it? The big radius is going to be the furthest right on the number line, 1, minus the this line, which is y equals -3, 1 minus -3. It looks like our big radius is 4. And that makes sense because we are a distance of 4 units from the axis. Small radius now is also going to be 1, our axis, minus, we take away this space. That space is, it needs to be in terms of x, so it is, oh, I'm going to use, yeah, that's radical x minus 3. Thankfully, I've solved it in terms of x. There was another silver lining to analyzing that. That's 1 minus radical x minus 3. We'll clean that up. That becomes, well, 1 minus radical x plus 3. That is 4 minus radical x. We have our 2 radii. The volume of this solid is going to be pi r squared, and our r is going to be the big circle, 4 squared, minus 4 minus radical x squared dx. And our x will range going from left to right, 0 to 4. Okay, hope that helps.